Hi, everybody. This is Homer back again. We're going to be starting chapter 14 on functional programming aspects of R. And this little screencast basically accompanies your reading of sections 14.1 and 14.2, kind of an overview of the idea of programming paradigms and roughly what functional programming is like. So these are just a series of exercises. They're similar to some observations that are pointed out in the textbook. They're based on a file, functional.r, that you'll find in your common folder so you can practice along with it as you watch this screencast. I'm starting off with a new R session and an empty global environment. So the first lesson is that functions are everywhere. Things in R that don't look like functions actually are function calls. For example, if you want to bind the name A to the value 5 in your global environment, then you would run line 3 here. And it would seem that all you get is that side effect, the binding of A to 5 over here in the global environment. After all, nothing's showing up down here in the console where I'm waving my mouse. But in reality, this A is 5 was a function call. It's actually the same thing as that. Another way of writing it in R is with these backticks around the assignment operator, and that makes it work like a regular function, with parentheses when you call it, and the first argument is the symbol that you want to use as the name, and the second argument is the value that you would like to assign to that name. So under the hood, what is really happening truly is a function. I could maybe demonstrate this to you by using parentheses around an assignment call. Parentheses around an R expression cause whatever is returned by that expression to be printed out visibly on into the console. So let's run B is 10 with parentheses around it. We get the side effect that the name B is bound to the value 10 over here in the global environment, but we also get what is returned by that function call. And what is returned, this is how it's programmed, is the value that the name was bound to. Let's look at line 8 here. C is D is 20. And you might intuitively guess it's going to bind both the name C and D to 20. Let's see if that happens. Yes, it does. But thinking of it in terms of function calls, we can see exactly why this works in R. D is 20 was a function call to the assignment operator. The side effect was binding the D to 20 in the global environment, but what was returned was the value 20. And then we have the next function call, the binding of C to what was returned, thus the binding of C to 20. And so that's why we got that second thing in the global environment. And of course, the value 20 was therefore returned because that's what the assignment operator's programming does. But you don't see a 20 in the console, and that's because assignment functions return their value invisibly. If you want to see the results, you have to use the parentheses. So lots of functions going on where you might not expect it. I'm going to clear out my global environment now. And let's make a little numeric vector of results that's just 4 long. We'll placeholder here. And we're going to store the squares of the first 4 whole numbers into results using a for loop. But notice that I have parentheses around my loop. So if this for loop is actually a function call in disguise, then I'm going to see what is returned out in the console. So let's run this. We get the desired side effects. Results is now the first 4 squares, but look down in the console, null. So the for loop is actually a function in disguise, and just like the function cat, it's programmed to return nothing, null. How about if statements? They're actually function calls in disguise as well. Here's another way to track what gets returned to them. Why not just bind the name stuff to the results of this function call in disguise? If A is bigger than 100, big. Now, I'd better actually set up an A again. How about let's bind A to 50, which is not big. Let's put that in our global. And now, let's run the assignment operator, stuff bound to the result of the if statement. And stuff turns out to be null. And that's not a surprise because A is not bigger than 100, so we never evaluate the expression inside the body of that if statement. Apparently, the if function, as it were, is written so that if you skip past its body, it returns null. On the other hand, what if you had, say, if A is 100 big, else small? So you're going to run one of those. You're going to run either the big or the small expression. Wonder what it's going to be returned this time. Well, let's let stuff2 be the result of that call, and we'll run it. Stuff2 turns out to be small because small was the expression that was actually evaluated in the course of looking at the if-else statement. So even that's a function in disguise. Not only is practically everything in R the result of some kind of function call, but functions themselves are what we call first-class citizens, which means that you can treat them like all the ordinary objects that you've worked with, literals like numbers and strings, vectors, and so on. You can do all kinds of things with them. You can put them in lists. You can multiply them together. You can you can assign them to things and so on, bind them to names, whatnot. Functions are like that too. So, for example, here, my things is a list made up of 2 elements. F is the function that squares its input, and Y is the number 7. So let's check on my things here. Look at that. Perfectly good list of 2 things where the first element is a function. Being first-class citizens, functions can be the value of that is returned by some other function. Here's an interesting example. Clown factory here. So clown factory is a function of 2 parameters, name and bag, which has a default value. Let me read this over a bit. Of the concatenation of $1 million in a new car. And in the body of the function, we bind the name clown to a function of no parameters, which cats out the name that was provided and checks on the length of the bag. If that bag is of length 0, then it cats out a sad message that the bag is empty. and returns. But otherwise, it samples a random number from 1 to the length of the bag, calls it the gift number, and it constructs a gift, which is going to be the bag at the gift number place. So it's going to be one of those two, one of those gifts that are in the bag, basically. It cats out here, have that gift, cats out a couple of new lines for looking nice, and then it takes bag but selects out gift number, thus removing that gift, binds the name bag to the result of that selection. And notice the 2 less than signs. This is what we call the super assignment operator. And so that means that this assignment takes place not just in the runtime environment of Clown here, but in the parent environment of it, which is the environment where this function is being defined. And that's the runtime environment of Clown Factory. The runtime environment of Clown Factory, you're going to have some bag that was provided. So that bag is going to have an item removed from it. Line 54 concludes the definition of clown. Line 55, where you just evaluate clown, is the final expression in the function's body that will be evaluated. So that's what Clown Factory will return. Let's go ahead and I'm going to clear my global environment. And put Clown Factory in it. And then let's make a clown. I'm going to bind the name Alfie to the result of Clown Factory, where name is Alfie and bag is goat, bicycle, and Ford F-150, several means of transportation, perhaps. Now, Alfie is a perfectly good function. So you could call Alfie. So let's see what happens. Alfie on line 65. Hello, my name is Alfie. Here, have a Ford F-150. Call her again. She picks one of the 2 remaining items in her bag. She says, here, have a bicycle. Call her again. There was only a goat left, so when she picks randomly, she has to pick the goat. And if we call her a 4th time, well, her bag is empty, so she returned with the cat of the sad message. So there is a perfectly good example of a function being the value returned by another function. Now, ideally, functions should be pure. In the concept of functional programming that you read about in chapter 14. This ideal cannot be met in practice for any programming language that plans to actually do stuff for you. But at least there are some impurities that you should be very careful to avoid. And one of them is for the function to change any values that are in your global environment. So for example, here's a very uncool func. It's a function of x, and as you can see, it's going to return the square of what it's given. But along the way, it super assigns the name y to surprise. So I'm going to bind the name uncool func to that function in my global environment. Uncool func is defined in the global environment. So logically, when it's run, what's going to happen is that up in the parent environment of the runtime environment of the function, a name y is going to get bound to surprise. So let me, before I run that function, first bind the name y to 10. And then when I run uncool func of 5, I get the 25 returned down in the console here. But I have the nasty surprise that the name y in the global environment is now bound to surprise. And so this is why our programmers should not go around super assigning within functions unless they're very, very careful, because you don't want to mess with any with any names in people's global environments that they plan to have bound to useful values they have other purposes for. The super assignment in the clown factory here, where we messed with the bag, was totally okay because the bag was something that existed in the runtime environment for Clown Factory. Nothing ever crept up into anybody's global environment. So the cool way to write the function would be you could just bind the name y to surprise and then square. And then all that's going to happen is that you return the square of the given x. The y is surprise would have no sort of long-term lasting effects outside of the runtime environment of the function. That's all for now. We'll study higher order functions, particularly in connection with the per R package in our next set of slides.